So let's delve deeper into understanding of the periodic table and kind of how it works for us and what information is contained therein. And let's talk about the boron, nitrogen, and carbon families. Remember that the families are represented in the vertical columns, and more often than not, they have similar chemical and physical properties. So let's just kind of point out on the periodic table exactly what we're talking about. So the boron family is group 3A, and the carbon family is group 4A, and the nitrogen family is group 5A. So let's see here, starting with boron in group 3A, what kind of properties we can say about the family. So for boron, these guys do not occur elementally in nature, and they're pretty scarce except for aluminum, which is one of the most abundant metals in our universe. And so these guys in the boron family have 3 valence electrons. And remember from your understanding of electron configurations and reactivities, kind of what that says about how it interacts with other elements and polyatomics and things of that nature, and what it means usually for its reactivity. These guys are metallic, except for boron, which is a metalloid. Remember that the metalloids have properties of both nonmetals and metals. And these guys are also chemically reactive at moderate temperatures, again, except for boron. So let's now talk about group 4A, which is the carbon family, which is quite possibly one of the most important elements represented on the periodic table, as carbon is the stuff of life. So in the carbon family, you've got 1 nonmetal, which is carbon. You've got 2 metals, tin and lead, and 2 metalloids, silicon and germanium. So these guys all have 4 valence electrons, and they tend to form covalent bonds. So that's very important. Remember that in a covalent bond, electrons are shared equally within the bond. One common compound you might think about is methane, which is CH4, or gas. Ability to combine with itself and long chains is another property of carbon, which a lot of other elements do not have. So carbon can form these really long chains where it's just bound to itself and other things usually. So it also exists in at least 3 allotropic forms. Remember what an allotrope is? And so for these 2 forms here are graphite and diamond. So these 2 guys, if you think about graphite and what you know about diamonds, you'll know that the physical properties of these guys are pretty different. Graphite's used in pencils, and it's just kind of like a lead property, and it can it's actually pretty soft, whereas diamonds are one of the hardest materials in the world. So let's now talk about nitrogen, the nitrogen family, which is group 5A, and nitrogen is really important because it is a part of the air that we breathe. So within the nitrogen family, you have your nonmetals, nitrogen and phosphorus, and your metalloids, arsenic and antimony, and your metal bismuth. So these guys have 5 valence electrons, and so in knowing that, we know that they form covalent compounds with oxidation numbers of +3 or +5. So in this, more specifically, I guess in this case, nitrogen tends to form a +5 oxidation state, and phosphorus forms a +3 oxidation state. And there we have our group 3A, 4A, and 5A elements.